Hello everyone and welcome to the Alpha Design team. My name is Arseny and I'm a video editor. I was also responsible for buying all the necessary equipment for this project.
Hi, I'm Brandon, and I coded the object detection and 3D printed our components.
Hi, my name is Peter, and I mostly managed and oversaw the project, helping wherever I was needed. My notable contributions are the graphical user interface and my part in the hardware assembly by getting the Raspberry Pi set up and the necessary libraries downloaded.
My name is Ryan, and I'm a part of the assembly team. I had the main role of designing 3D enclosures for the Raspberry Pi and the Kumon 7-inch touchscreen device.
Hi, my name is Samin, and I was in the software team for this project. My role was to write the code for sending the email notification to the house owner.
Hi, my name is Taiba and I was on the hardware team for this project. My main role was to work on the 3D model of the adjustable camera enclosure.
Hi, I'm Utku, and I was in the software team for this project. I wrote the code for face detection, I combined everyone's code to make the system, I handled and debugged errors, and I also helped with the installation of the necessary libraries for the Raspberry Pi.
Hi, this is Felix. I was doing part of the research and hardware job for our group project, and I was also participating in debugging and testing our whole system.
The objective of our project is to tackle security issues that we face every day. Break-ins and thieves have been increasing in Vancouver, according to CBC News, and safety is a major concern that needs to be addressed.
This is the face detection function I wrote for the project. The function uses the Python OpenCV library, and the library uses something called caskets to identify a human face. The parameters the function is looking for is given in the faceCasket.detect multiscale function. It also draws a rectangle around the face when it finds a human face. In the end, it returns a 1 if it detects a face, and it returns a 0 if it does not. This is really important in the later stage when we decide to send an email or not.
This here is my object detection code. This is the names of the objects. This is the file for the object detection. This is the file detection settings. This here is while the loop is true, it will do the object detection. This is the boxes around the object. These are the settings for the boxes, and this is how it works.
Okay, so to explain how the code works for sending the email, we need to connect to the CSMTP-lib library, and then that allows us to connect to the Gmail server IP using this. And then we have the email address and the password so we can send the email to the person we want. And then as the program is run, when we open the email, we should receive the image.
For the GUI, I had to import the takeinter library, and that's how I was able to make the basis of the GUI. I defined two functions, one being the security arm where it would detect the face and it would email the user with the picture that it takes. The other function I defined was the live video feed, and after that I simply had to format the GUI and add two buttons, each button calling one of the functions, and that's how pretty much the GUI works.
The system is made up of a Raspberry Pi, a microSD card, the screen, and the infrared camera. How it works is that the camera would be placed above the door and it would detect any number of people that appear in that area. It will then notify the house owner by sending them an email with a picture attached and timestamped.
The enclosures made to fit the camera, Raspberry Pi, and screen were designed by Ryan and I. I worked on the enclosure for the camera on Tinkercad, as well as the adjustable case that it is attached to. Designing the back sections was difficult at first, but I figured out how to make it in a way such that the bolts and nuts can tighten and loosen to adjust the camera easily.
So the enclosure slides into the cover and clicks shut, locking in place. It also has 4 pillars for the 3 frontal ports to fit inside, as well as 4 circular protrusions that allow the Raspberry Pi to be screwed together with the base of the case. The cover has holes for the base to slide into and clicks the system together. There are plenty of holes for the ports, micro SD cord, and that ribbon cable. I also designed the cage to feature our project's nickname, Serb. The Kumon 7-inch touchscreen has an interior enclosure that protects the front and sides of the Raspberry Pi while leaving a hole for the screen to be visual. The frontal enclosure also has holes on its side for the HDMI port and the 2 micro SD ports. The posterior enclosure just functions to provide protection to the back of the Kumon touchscreen device. It snap fits into the interior closure, but it has holes as a backup in case the 3D printer malfunctions.
This is Cerberus. This is the screen, the graphical user interface, the Raspberry Pi, and finally, the camera. Now I will step to the side where I'm outside the angle of view of the camera, and I will arm security as you would in your own house. Now, once I step into the frame, the Cerberus will detect my face, take a picture, timestamp it, and send it to my email that's open to the side. Now, any moment now, I should be getting an email saying someone is at my door. And voila! It says someone is at my door, and it has a timestamp. Now, our project also has one more feature. For example, when this is outside your house and the ribbon cable goes into your house where this is located, you can have the Cerberus show you a live video feed of what's happening outside. And this allows it to detect my face and show you exactly what Cerberus sees. It even works in the dark. If I turn off my lights, as you can see, it can still detect my face no matter where I go. Now walk away. Okay guys, go ahead and walk. And then you guys can walk off now.